Okay. Hey, what's up, guys? Welcome back. I had to do a few things off screen, which, restarting my computer to enable virtualization works now. So I was able to install this command line tool, which is something that this article here recommends because we're going to be installing Redis, which is like, what exactly is Redis? Contains, okay, so Redis, what is this? What is Redis? For the networking part of the course, there's a Redis alternative. There's a Redis alternative if you don't want to spend a lot of time setting up locally. Okay. Um, let's actually see what this is. I don't know what Redis is. Okay, it doesn't know what Redis is because we don't even have it installed, which is something we need to do. So let's get it in there. There we go. Just make sure my microphone is the same. Yeah, it is. Okay. All right, let's get Redis installed. It's probably gonna take some time. We're just updating apt-get, I guess. Alright, so that all worked out well. Let's do this. Didn't ask me for my password, so that was good. Alright, so then let's install GCC. I don't know what Redis is. But apparently it's a way of, like, monitoring networks. And there's another installation guide. Which is apparently, like, what we have to do. You have to follow this article to, like, install it, apparently. Okay, let's see. There's a quick start document that targets people that... This is a quick start document that's for people who don't know anything about Redis. Okay. Alright, so... Yeah, we pretty much already did all this stuff. Now, let's install Redis. So then we're gonna, like, unzip this. And then we run make. It's gonna take some time. What is Redis? Open source in-memory data structure store used as a database, cache, and messenger. Provides data structures. What? Such as strings, hashes, lists, sets, store bitmaps, hyperlogs, and streams. Okay, that doesn't really explain what it is. Now I keep opening that. Now, how do we actually see if this works? Okay, so we don't have these in their proper places, apparently, so we need to move them. Oh, we're not even in there. Hold on. Okay. That seemed to work. Alright, you know what? Let's try this. So I think we should be able to do this now. Okay, so Redis CLI. Let's see what this is. Um, huh, that's interesting. Alright, so that's kind of cool. We got Redis installed. Hopefully we won't, I mean, we'll use it in here technically, but yeah. Okay, let's continue on. If you can run above, all good. Feel free to get a head start on downloading Redis. So we don't, like, we already have this installed on the Ubuntu, so that's definitely a good thing. Did you do, okay, yeah, so that's, however, the course has been refactored. Okay, so I don't know when we'll use Redis, so I'm just going to keep this closed for now. But let's continue reading this. Mega JavaScript overview. Yeah, I mean, I already know JavaScript, so I don't think I'll do that. That being said, these are all super important stuff, but I mean, if you don't know JavaScript, that is, like, I already have, like, a good understanding of these. Alright, let's start building the cryptocurrency. Okay, I think we should be ready. This is like the back end of the blockchain. Alright, ready? Are you ready? Are you ready? I know I'm ready. Let's start it.
Hello, welcome to the first coding video of the course. In this video, we'll focus on setting up the overall blockchain and cryptocurrency project. We're going to create a new project folder on our system and install some libraries. For this blockchain project, we're going to use Node.js as our backend JavaScript engine. Now, you may be familiar with JavaScript if you've done some web development. But if you need a quick overview of the language, go ahead and watch the optional JavaScript mega overview that is in this course. This also means that you'll need Node.js installed on your system. Now, a quick way to find out if you have Node is to run node-v in your command line. So go ahead and open up your command line application and run node-v. And if you see some output, anything higher than version 8 should be fine, and therefore you have Node.
We should be good.
As for command line apps itself, if you're on macOS, my preferred command line application is iTerm2, but the native terminal application is good as well. That applies to Linux as well. Terminal is just fine. And if you're on Windows, I absolutely highly recommend using Git Bash because it offers the same Unix environment through Bash that we'll use on macOS here in this course as well as Linux. You can also install the Linux beta on your Windows machine to access a Bash environment as well. And the benefit to that is that if you're interested in software engineering, a lot of remote servers are going to be using Bash, so it's really recommended to know Bash and learn it. Cool. Another command to check is npm, which is installed automatically with Node. So with npm-v, anything higher than version 5 should be just fine.
Yep.
With Node and npm available, let's make the project. So we can use the mkdir command to make a directory, and this time I'll make a project called CryptoChain. So mkdir, and this project is going to be called CryptoChain. And that is going to be the project for this overall course. Go ahead and navigate into the directory with the cd command, and once you start typing in most of the name of the folder, you can use tab to automatically complete. I'll clear so that way the terminal is nice and clear. And then we can turn this into a Node.js project with the npm init command. We'll use npm init, and we'll also provide the -y option, which will answer yes to all the questions of the interactive questionnaire, which usually accompanies npm init. Now we can always edit those answers to that interactive questionnaire later, which essentially customizes the output to this package.json file. This package.json file is used to specify the details about the Node.js project, such as its name and its author. Now we'll come back and edit this file later. For now, the next step is to install our first Node.js library, Jest. Jest is a JavaScript library that runs tests on JavaScript code, and we're going to use it to make sure that our blockchain logic is working properly. So install Jest with the npm install command. Now a shortcut for install is npm-i, so we'll actually use npm-i. The name of the library is Jest, and to be compatible with the version of the project that is used in this course, use an @ at 23.6.0, and we'll also use the --save dev flag, which will mark Jest as a library dependency that we're going to be using in development of this project. So as we save this, it's going to install Jest as a development dependency in the CryptoChain project. So it's going to install, and then once we have that installed, we're going to want to check out the package.json file by doing a cat of package.json, which will print out the package.json contents to the actual command line. And what we see is this new dev dependencies section with Jest specified as well as the version number. Cool, so that completes the initial project setup. Next, let's start creating the first bit of logic for this blockchain application.
Okay, so I just gotta wait for this to finish. All right. I mean, so far so good. Let's open this up in code just to make sure. Keep that closed for now. Okay, so what do we have to do here? The block class.
Let's start creating the blockchain. We'll begin by building the most fundamental unit of the blockchain, the block. After all, to make a chain of blocks, well, we need the individual blocks themselves. At the core, blocks consist of 4 pieces of data. First, we give blocks a timestamp.
So every block has a timestamp, which is like the number of milliseconds from the year 1970.
To record when they were created. The timestamp will be created with the JavaScript date object, which allows us to specify unique times down to the millisecond. Next, we give the block an attribute called last hash, which is the hash of the block that came before it. Recalling information from the blockchain overview at the beginning of this course, the hash is a unique value for a block that is generated based on all of its unique data fields. So the last hash refers to the hash of the block that came before. Third, we have the data that we want to store within the block itself, whether that's a string, an array of numbers, an array of anything, or an entire JavaScript object that represents transactions or any other kind of data. Fourth and finally, we have the hash itself for the new block, which is generated from all of its own data. In summary, every block consists of its timestamp, last hash, data, and individual
Which we sort of looked at previously when we were, doing the 10-minute stuff.
hash. With that in mind, let's create our first class in
So
the
now this is
project, a
surprising.
JavaScript class called block. So head to the command line, and then go ahead and open up your project in your preferred code editor. I like to use Visual Studio Code myself. So to start, I'm going to make a block.js file right at the root. Do the same. So we're going to have a block.js file right at the root of the project. And we'll start by declaring a class called block with the class keyword, and the name of the class is capital B block with a pair of curly braces as the body. Every class has a constructor method, so let's provide the constructor method with its pair of parentheses and its pair of curly braces for the body. With the constructor, the block class will receive values within individual instances of the block. For this block class, we'll have the constructor take in 4 arguments for unique values for the block. And these arguments are going to be the timestamp, the last hash, the hash, and the data field, which is all those things that we just reviewed in that overview of what comprises a block. Within the constructor now, we'll then take these incoming values and set a property on the class for each value. To set a property on the instance of this class, we use the this keyword, and this is a special keyword that allows a class to refer to any individual instance of the class as that instance is being interacted with. Now this concept is best understood in code, so this will make more sense once we've completed the constructor method and we've created an instance of this block class. But what we want to do is we want to set a field for every argument into this constructor according to the instance of this block. So for example, this .timestamp is going to be equal to the incoming timestamp. This .last hash is going to be equal to the incoming last hash. The hash, again, is going to be equal to the incoming hash. And finally, we have the data field itself. Nice. That completes the block class. Now for some instances. We create an instance using the new keyword. Let's create a new instance at the bottom of this file by using the new keyword, and we're going to say we want a new block instance from the block class. Let's also assign this instance to a variable. We're going to call this block1, and we're going to use a constant. Constants in JavaScript can't be reassigned after they've already been declared, so it's a handy way to create a variable to make sure that the variable is safe throughout the course of the program. And now we can pass in some relevant values for this block instance. Let's use some dummy values. So for the timestamp, how about 010101? This can be anything for now. We just want to see what an instance of this block will look like. Let's call this foo last hash. Likewise, we'll have foo hash and also foo data. Nice. And finally, let's console.log the block1 in a string so we can identify what is being logged, and then as the second argument, the object itself. Nice. Let's head back to the command line now that we have these changes. Let's go ahead and run the file So I'm going to run node and block.js. And what we get as the output is that block1 is an object of the block class type and it has all the relevant fields that we passed into the constructor. So this block1's block timestamp is what we pass in as the first argument, and following from the last hash to the data, it's whatever we pass in to the constructor. Very cool. Now, if you're wondering how I'm resizing my windows very quickly, I'm using an application called SizeUp. It is a paid developer tool, and I use it because I've already memorized the shortcuts, but there are free alternatives out there, and this is something that I mentioned previously when doing the JavaScript overview. All right, cool. So mission accomplished. We created a block with a timestamp, a last hash, a hash, and a data. Very nice. Now that completes the basic building block, literally, of the blockchain. Before we move on though, let's make a slight improvement to how this block class is currently structured. As a best practice in coding, I prefer to wrap functions in a map-like key-value structure when there are a high number of arguments. I consider 3 or more arguments pretty high. So notice that for the constructor of the block, we currently have 4 arguments. So let's wrap this whole thing within a pair of curly braces. So all the arguments within the constructor are now within a pair of curly braces. The advantage of wrapping the arguments in an object like this is that you don't have to remember the order of the arguments when you create instances later on. Order might seem like a very small thing to care about, but it's actually one of the most hard to pinpoint issues when it becomes one in large software projects. Small improvements like using a map for a function argument makes a huge difference in making sure things are consistent when you're calling code. So this is going to require us to update the block1 instance arguments. So overall, let's wrap this whole part within an object, and we need to specify each value according to their object key. So the first one is a timestamp. The second one is the last hash. The third one is the hash. And the final one is the data. Nice. And to prove the point of not caring about order, let's accidentally put the timestamp last. Or let's say we just wanted the timestamp last. We can even make the data the first part as well. So if we have data first, it shouldn't matter because when we still run the file over again, we see that the timestamp is still 010101, the last hash is still the last hash, the hash is still properly the hash.
Okay, the ordering doesn't really matter. That's literally all he's saying. Like, you can put this over here, as long as everything's spelled correctly. I guess that's all fine. Okay.
And the data is still the data. Awesome. The result is just the same. Great work. With our block class created now, let's move on.
Okay, so this is like test-driven development. So the way it works is you like write some code and you like run some code to test it out and stuff. So that's pretty useful, honestly.
Hey there. Previously, we created the block class. Chained together, these block instances will be the individual units of a larger blockchain. Now, before we jump forward to a new feature though, let's take this opportunity to adopt a test-driven development approach to this project. So test-driven development is an approach to programming where indeed, well, you test everything. But the extra catch is that you write the tests first. So the practice goes like this. You write some tests. Then you get those tests to fail. So make sure those tests are red. Then you write the code to get those tests to pass one by one. You keep going until all the tests are passing and green. Once all the tests have passed, it's time to move on to the next feature by writing a new set of tests. Now, if it's your first time with test-driven development, this may seem like a really odd and backwards way to code. It's true that the style does take a little getting used to, but there are 3 main reasons why test-driven development will benefit us greatly, and it's a perfect approach in developing this blockchain project. The first reason is that this will give us a lot of confidence that our code works reliably. As we add new features, we can be sure that old code still functions properly as long as the tests pass. The second reason, Test-driven development will actually speed up the coding process, believe it or not. Without test-driven development, you need to run the entire application to test any new feature that you add. You might end up having to go through more functionality than you need to only test out and experiment with a new feature that you added. However, test-driven development allows you to hone in on one specific piece of the code by focusing on the test or tests for that new content. And the third reason, and the most important one, is that test-driven development will give you, as a student, an opportunity to apply your knowledge and the concepts you learn without always seeing the actual code and logic first. Meaning, once the tests are written down, the implementation can completely be up to you. As long as you get the test to pass, you can be sure that your code supports the relevant feature in the blockchain system. So anytime you want to take up a learning opportunity and a challenge, go ahead and pause the lecture once the tests are written, and then try and implement the actual logic yourself. There'll always be an answer later on, so be rest assured that you can watch the coding logic to get the test to pass. With that in mind, let's consider how we would have developed the block class with test-driven development. First up, back in the block.js file, let's remove all this experimentation code, so we'll get rid of block1 as well as the console.log. And then go ahead and comment out everything within the class block itself. So make sure the constructor is actually commented out. I highlighted and then I use command/ to automatically comment out all those lines.
Or control.
Before we move on to the test, we will add one new line though. At the end of the file, let's add code to make sure this class is shareable with other files. So we do that with module.exports equals block, which is the Node.js sharing code syntax between files. Cool. Now let's suppose we originally developed this class with test-driven development, which starts by making a block.test.js file. So notice that the file name is almost exactly the same, except it has this extra .test extension before .js. Cool. I'll make this full screen as well. Next, we'll set up an overall test using a keyword of the Jest library called describe. So we call describe, and then usually the very top is the name of the block class that we're actually testing. So in that case, it is capital B block. So that's the first argument to the describe function, the name for the actual group of tests. The second argument to describe is a JavaScript function that it can run. So this is going to be a callback function. We create a callback with our arrow function syntax, parentheses, equals then sign, greater than sign, and then a pair of curly braces. In this describe block, we can then set up a few variables and then write tests around those variables. So we're going to set up some variables for the following tests. First, let's declare a variable for every relevant field for a block. So we're going to have a timestamp constant. Likewise, we want a last hash constant. We want the hash constant, the data constant, as well as the overall block itself in another constant. And then we'll assign values to each constant. So the timestamp, let's have a dummy value. So let's have a string that says a date. The last hash, well, we can make that anything. So how about foo hash? The hash itself can also be anything. Bar hash is a nice dummy value. Again, we're following this trend of making dummy values. So for data, how about an array of a string that says blockchain and another string of data? And then finally, the block is going to be a block that consists of all of these fields. So we'll make a new block whose timestamp is that timestamp variable, whose last hash is that last hash variable. And this trend is going to continue. So the hash is the hash and the data is that data field. Now notice that all of these key values are the same for the block. In JavaScript, if the key and the value are the same in an object, we can use a shorter syntax, which essentially makes it so that you only have to specify these fields once. So you only have to write timestamp once, and then last hash once, and then hash once. And the great thing about this is that these keys are automatically used, and the value is whatever the value is stored as in the local variable for that actual keyword. Cool. So this sets up all the variables in our group of tests within this describe block. Now let's write our first test. For this first test, we'll write one that ensures that every block has all the properties we just went over: the timestamp, the last hash, the hash, and the data. And to create a test, we use the it function. It is very similar to the describe function. It takes a string message as the first argument. And as the second argument, it takes a callback function to run. For this message, let's say that a block has a timestamp, a last hash, hash, and data property. So this will be our first test. It's enforcing that all these properties exist on the block. And then we have our callback as the second parameter to the it function. And notice that we're wording our message in a way such that it reads nicely with the it function name. It has ... So it's nicely oriented so that this testing file is very readable. Within the it function, in order to run a test, well, we provide an expect statement. So the expect function takes one argument, a value to test the value upon. So this is the actual value. So the actual value is a block.timestamp. And we want this to match something. And to match something, we use a toEqual function. So we'll expect the block.timestamp to equal the timestamp variable that we originally declared. So this is the expected value within toEqual, and then the actual value is a block.timestamp, which goes within the expect function itself. Nice. We can do the same for the last hash, hash, and data. So I'm going to copy and paste this line 3 times. I'll use Command D to edit both of these. So that way I get block.lastHash is equal to last hash, block.hash is equal to hash, and block.data is equal to data. So make sure you have all of those expect statements. Now it's worth mentioning that having more than one expect statement in the it function isn't a best practice. It's usually best to have one expect per it function. However, once you get more practice with test-driven development, we can worry about maintaining proper coding conventions. The focus right now is to give test-driven development a spin. So this completes the overall block.test.js file. Now let's get to actually running the tests. Previously, we installed Jest as a development dependency in the project. So Jest is going to run this test on our behalf. To fire Jest, let's add a new script, or rather edit the existing script within the package.json file of the project. So in the local package.json file, notice that there is a default test command specified. And instead of this echo business and exit business, let's call Jest. We'll also provide a watch all argument to Jest. Overall, this will tell Jest to run any files that have that .test.js extension. Cool. So once you have that, head back to the command line. And what we want to run is npm run test right within the command line. All right, and as we do so, it's going to run that block.test.js file. And what we have is red output, a fail overall on our new block.test.js file. But this is actually a good thing in test-driven development. It points out things that we need to write in order to get this test to pass. Now, the first thing it's doing is it's saying his block is not defined, and that's actually an error in our block.test.js file. We need to require this block class at the top. So let's make a constant of block, and this is the syntax for requiring code within Node.js. We use the require keyword, and then when we point to the file where the code is located, and then we set that export to a local variable. So this will make the block class that was exported in the block.js file available in this test. And notice that we don't have to specify .js. .js is implicitly specified by Node itself. As we save this, back in the test now, it should rerun. And this time, we still have a failing test, but the error is different. This time, the first test failed. We're expecting the value to equal a date, but instead we received undefined. And now the goal is through test-driven development to get these tests to pass one at a time. So on the left, I'll have the testing file, and on the right, I'll have the code. And what we want to do is bring back this constructor. So I'll uncomment this out, just the constructor line first. So overall, the constructor will have the timestamp, the last hash, the hash, and the data. And the first thing that it's missing is the timestamp. So I'll uncomment that, and I'll set it back in. And now we get a second New error, and this time it's the foo hash, which is that last hash value that it's expecting. So if we uncomment that, well, again, the error is different now, and this time it's the hash. And finally, we get the data portion. And with all of that, we're all green, and the block class is now complete. Pretty epic, huh? In all honesty, it was probably a little underwhelming for all the cloud task-driven development gets from experienced programmers. But really, that's all there is to the approach. You write the tests first, you see red filling tests, then you get to do the fun stuff and get the actual code in to get the test to pass and find a green suite again. Right now, the benefits of test-driven development might not be super obvious, but that's because test-driven development comes most in handy as a project grows and becomes large. So as our blockchain project continues to develop, test-driven development would become an extremely helpful programming style. All right, see you in the next one. Hey, in this video, we're going to create the blockchain's Genesis block. So to understand the purpose of the Genesis block, consider that the blockchain is a chain of block objects. Each block generates its hash based off of its own data, but also the last hash of the block that came before it. But what about the first block in the chain? What should its data be? And what about its last hash value? Well, it's the first block. So how can it grab the last hash of the previous block if there's no block before it? This is why blockchains have the concept of the Genesis block.
The first thing in the blockchain.
It's the origin of the blockchain, and the Genesis block is hard-coded with dummy values for its timestamp, its last hash, its data, and its hash. That way, the blockchain has something to get started based off of. And when someone actually adds the first new block to the chain, the first block can set its last hash to the hash of the Genesis block. All right, cool. Let's create this Genesis block in code. So our overall goal is to define a new function in the block class called Genesis. This Genesis function should create an instance of the block class with hard-coded values for the Genesis block. First, let's define those hard-coded values in a new file in the project called config.js. So at the root of the project, let's make this config.js file. This config.js file will serve as a place where we store hard-coded and global values. Our first global value will be an object called Genesis data. And notice that Genesis data has a funny looking syntax. It's in all caps, and when you combine words, you use an underscore. This is called the screen case syntax. And the screen case syntax is a widely used software syntax because it makes it immediately obvious that the code is using a hard-coded global value. It really grabs your attention. In this Genesis data object, we can define hard-coded values for every part of the block for the Genesis block. For the timestamp, let's make the timestamp 1. The last hash can be like 5 dashes. It's a hard-coded value, so you can really make it anything you want. The hash, to make it clear, let's call this hash 1, but again, you can make that anything you want as well. And for the data, let's make it an empty array. Nice. As the last step, let's share this Genesis data object with other files. We'll export it within an object itself. So we'll call module.exports equals an object, and within here, we'll input the Genesis data. So this will have a Genesis data key within this object, and the value for that will be this Genesis data object itself. All right, cool. Now let's head back to block.test.js. First, we're going to add a new section with a describe block. So right within the describe block at the end, well, let's add a second describe. And this will describe another group of tests for the overall block test itself. And this one is going to describe the test for a Genesis function. So the message is Genesis with a pair of parentheses itself. The second parameter to describe is still the callback function. Cool. And to start, we're going to add a new constant for this block. And this will describe another group of tests for the overall block test itself. And this one is going to describe the test for a Genesis function. So the message is Genesis with a pair of parentheses itself. The second parameter to describe is still the callback function. Cool. And to start, we're going to add a new constant for this block of tests called Genesis block. Let's make a constant called Genesis block, and this time we'll camel case it. And then this is going to be the result of calling block.genesis. So not on an instance of the block, but on the block class name itself. And notice that I spelled const incorrectly, so there we go. That's why my code editor was complaining a little bit about the Genesis block, but this line is now fine. So you may be curious how we're going to be able to call the Genesis function from the block class without creating an instance of the class just yet. This is an example of calling a static function in JavaScript. Static functions are convenient when you don't need to use or change the data on a specific instance of the class, but you still want to contain some functionality within a class name itself. So that's what this Genesis function is going to be. It's going to be a static function on the block. It doesn't need to be particular to any block instance itself, but it's useful and pertinent to a block. So that's why the Genesis function is going to be contained there. All right. Now this concept is better understood in code, so we'll get to that soon. First though, let's make our first test that says it returns a block instance. So we have our it block, and the test says it returns a block instance. And then we have our second argument, which is a callback function as well. For the test, we'll have our expect statement. And this time we'll expect the Genesis block to be an instance of the block. In JavaScript, we have this instance of function, which returns a true or false value, depending on whether or not the first part of the statement is the type of the second part of the statement. So we'll expect this to equal true because we want the Genesis block to be a block instance. Now, when it comes to true or false expectations though, let's use the more idiomatic just function, which is to be. Cool. Now for our next test, let's expect it to return the Genesis data that we defined. So as the second test for the Genesis block, we have a second it statement, and this will check whether it returns the Genesis data. The same format with the callback as the second parameter. And this time we'll expect the Genesis block itself to be equal to that Genesis data that we defined within our config.js file. Now, again, you may be curious about how this instance of this block class can be equal to a Genesis data object that isn't an instance of the block class. After all, aren't they different types of data? Well, the answer is that JavaScript implements classes as objects under the hood. So an instance of the block class with Genesis data is essentially that Genesis data object itself, because it's going to have the same properties, meaning it will have those same keys and values of the timestamp, the last hash, the hash, and the data. So now that we're using Genesis data, well, the last thing that we need to do after you have this whole describe block and all of the changes is to require the Genesis data itself. So at the top of the file, we're going to use the Genesis data, and we're going to require that from the config file. And notice that when we require it, we also surround it within a pair of curly braces to get the Genesis data, since the Genesis data was exported in an object. Cool. That completes a test for the Genesis functionality. So let's run the test suite in the command line and see how these tests go. So in the command line now, well, if you already have Jest running in the background, it's going to pick up that new test. But you can also run npm run test in the crypto chain project to get the test to run again. And still, we see the same error where block.genesis is not a function. Okay, that's great. As expected, we're getting a red test suite, as with test-driven development. The next part is to get these tests to green in order to complete the Genesis functionality. And let's do that next. But do feel free to take this opportunity to implement the Genesis function yourself. Hint, you'll want to implement the static Genesis function and return a block instance that uses the Genesis data.
So let's see if I know what he's talking about. And essentially, block genesis would be the the block. So is that actually how you do it? Let me see. Okay, so the keyword is static and then static method, and then you just return the static method. Okay, so let me think if I know how to do this. We also want to import the Genesis data, right? So let's do that too. Okay, so let's look at our test suite. So it does not return a block instance, and it does not return the Genesis data. So 2 of these test suites failed, technically. So it returns the Genesis data. Okay, so we're not really doing that yet. The so 2 of these are false, right? So Genesis block is not the Genesis data, so let's set that up. So how would you do this? New block. Timestamp. Oh, wait. Okay, so this is already an object, right? So we don't have to like do anything else. I'm pretty sure the test suites will pass. Let's find out. It's a bit confusing. Expected, received. Strange. Okay, yeah, I don't know why it's failing. Okay, let's figure this out.
Cool. Otherwise, if you'd rather move on with the project at a quicker pace, do go right ahead to the next video where we cover the block.genesis code. Welcome back. The goal is to get these red Genesis block tests to green. First up, you'd probably benefit from having your command line application and your code editor open at the same time. As you make changes to the project, Jess will rerun the tests and update whether or not those tests are still failing or now passing based on the changes. Cool. So I'll place this on the left, the test that is on the left, and then the code on the right. So I'll put this on the right next to the tests. All right, to get these tests to pass, we go to the block.js file. And then the first error is that block.genesis is not a function. Therefore, let's declare the genesis function, but we want this to be used in the static context. So we'll use the static keyword. And as this saves, notice that the test suite is updated. And this time we're getting a pair of failures for both of our tests relating to the Genesis block. Cool, so now that Genesis actually exists, you can get past that initial error. And now this time, well, we want to return a block instance. So let's return a new instance of the block class itself. And notice that in the static context, we can actually refer to the class name, even though Genesis is contained within the block class. Nice. And now we have a more isolated but different error. This time it can't destructure the timestamp of undefined or null. Basically, it's saying that this block doesn't contain any data. The data that we want to return is that Genesis data though. So let's require that at the top of the file. This is going to be a Genesis data import from the curly braces, since the config file exports it within an object. So let's grab the Genesis data from the local config file. And now that we have this, we can use the Genesis data as the input to an entirely new block. And as we save this, all the tests are now passing. Very cool.
Hmm. Why is this failing? Wait, I think I know why it's failing. Haha. Okay, so it expects a boolean. Haha, I'm so dumb. So what we have is correct. I just didn't write this correctly. So our test is right. We're just not. Okay, that. Oh, okay. I don't know what happened. Hold on. Okay. Yeah, I'm gonna have to like stop the stream because I did something that I don't know what I did.